I got 258 over 270 in my A-level chemistry exam, and this is how I beat the examiner.
Okay, so we're going to start with this question, really basic, pH, yeah? pH equals minus log Ka. Just put it in, you're going to get 4.87 for that. Let's go to part 2. Now, a buffer resists small changes in pH when we add an acid or a base, right? And ammonia is a base. Cool. We should just know that off jump. And I'm going to write that into my answer. Cool. Bases accept protons. Calm. So that means that our concentration of the H plus ions is going to go down here, right? Cool. If that goes down, then our equilibrium is going to shift to the right to replenish those protons, meaning that we can put that in our answer, get our second mark. Now, the calculation is always going to be the toughest part here. So, I start with the equation. I've written out the ionic equation for what's going on here. Yeah? Now, let's work out the moles of magnesium. So, we do the mass divided by the MR, we get 0.25 moles. Cool. I'm also going to work out the moles of our buffer. So, they've told us that it's 1 decimeter cubed. They've also told us that both of the concentrations are 1 mole per dm cubed, meaning 1 times 1, we just will get that it's 1 mole. Cool. Now, very important part. If there's 2 moles of the acid reacting for each mole of magnesium, and we know because it's a buffer, that the acid is going to be in excess, right? We're going to need 2 bouts of magnesium in the reaction, yeah? It's happened, and it's happened again. So, I'm going to multiply the moles of magnesium by 2, right? It's reacting with the acid to form our A minus, right? So, it's reacting with HA to form A minus. So, I'm going to take away the moles from HA. I'm going to add them onto A minus. So, that's why we're going to have 0.5 moles of HA, and we're going to have 1.5 moles of A minus. Yeah? Also, again, we were told that it's 1 decimeter cubed. So, I can work out the concentration. Fine. Cool. Got that. Now, we're going to use our Ka formula. As we do, we're going to rearrange it for H plus, as I've done on the right here. When we do that, put in your values that I've done below. We're going to have 4.5 times 10 to the minus 6 mole per dm cubed is going to be our concentration of H plus. And we know the formula, minus log the concentration of H plus is equal to the pH, and we'll end with 5.3.